Alrighty, hey there everybody. So in this video we are going to talk about what makes up complex numbers, and in another video when we get to it we're going to do some operations with our complex numbers. So when we start talking about complex numbers, what we are going to introduce is what we call our imaginary unit, the letter I. Because what we're going to find out is if I tell you x squared is equal to -1, that means x cannot have a real value. Because if we have x squared equals -1, we are going to figure out what this is saying. If we take the square root of both sides, we can't take a square root of -1 because nothing times itself is ever a negative. A positive times a positive is a positive times a negative is a positive. So we identify the square root of -1 as our first imaginary number, which is I. I is the square root of -1. And then if we square I squared is going to be -1. The reason why is we can see right here, I equals the square root of -1. So if we take the square root of -1, and we square it, squaring a square root just leaves the value by itself. So -1 is I squared. We usually do I like to do it as a cursive because I can't do an italic. So when we have a complex number here, because that's what you're thinking about, hey, we said we're going to do complex numbers, and now you're talking just about imaginary numbers. Complex numbers are going to be when we put a real portion and an imaginary portion together. And I always lets us know about our imaginary portion. So if A and B are any real numbers, then any number in the form A plus BI is what we call a complex number. In the complex number, A is the real part and B is the imaginary part. A is my real part and B is the imaginary part. And I know it's the imaginary part because of the letter I. The letter I means imaginary. That's why I is never a variable in a math class. So they kind of break down our numbers and how they relate to each other, our number system. On the left side over here, we have all the real numbers. All the real numbers. Right here, notice they have our complex numbers, but they're saying B has to be 0. That means we have no imaginary part. We have our rational numbers and our irrational numbers. Those are our two main groups. And inside of our rationals, we have the integers, the whole numbers, and the natural numbers. So natural numbers are the most specific group. And then we had our whole numbers by adding 0 to the natural numbers. And then we have integers where we bring in our negatives. And then the rational numbers bring in fractions and decimals. And then the irrational numbers are any real number that I can't write as a fraction. Or, yeah, I can't write as a fraction. The decimal value repeats forever and never repeats a pattern. On the right side, here are all of my complex numbers, my non-real numbers, my imaginary values. And at some point, we took the square root of a negative number. So if I give you the expression, the square root of -a, if a is going to be some value greater than 0, then the square root of -a can be rewritten as I times the square root of a. What this is saying, if, for instance, if I give you the square root of -16, let's write this as a product of a real number and I using this definition. Okay. So what this means is the square root of -16 means let's change pens. We're going to make this a positive radical by taking out our I. And then the square root of 16 is 4. So the square root of -16 is 4I. Boom. Easy peasy. Breaking down this example. Let's do the square root of -70 as a real number and I. So we know we're going to do I radical 70. I lets me know that it was an imaginary number. I know it's imaginary because we're taking the square root of a negative. Can't do that. So what we do with our 70. I want to see if this breaks down, if I can simplify that radical. Because if you put it in a calculator, it's just going to give you a decimal. So the method I like to use is called the L method. Some people like factor trees. I'm going to do the 70. I'm going to divide it by 2 because 2 is a prime number. Everything on the outside of these L's is going to be a prime number. And when I get right here to a prime number, I stop. And then I ask myself, are there any pairs of numbers? Because another way to write the square root of 70 is to say the square root of 2 times 5 times 7. And none of these numbers multiplied together give me a perfect square. So this is my final answer. Boom. You could have also used factor trees to find your perfect squares. So using the idea of perfect squares, I want you to go ahead and try this one, and we'll get together in class. We'll talk about how we did that. Boom. So make sure you come with questions if you have them. Alrighty. So as a general reminder, and I'm going to talk about this again in the next video. So when we work with negative radicands, before I do any work with the radical, do this rule first. I can't do any of the rules until I take out the I. So in particular, the rule square root of C times the square root of D, we have to do our I's first. Here's why. If I take the square root of negative C and I'm going to multiply that by the square root of negative D, so if you were not to apply our negative radical rule, that would give you the square root of CD, and that is a real number. Well, we're not going to do that because here we've got these imaginary numbers. So that's not true. That's not true. So what we're going to do, we can't do that. What we're going to do instead is we're going to turn this to an I, and that's going to be radical C times I radical D. So then that's going to give me I times I, which is I squared times the square root of CD. And what we learned earlier is I squared is negative 1 times CD, or just negative CD. So you want these answers, notice, are not the same. So do your I rules first. So let's see if we can do some of those. I know I said I was going to stop the video, but I changed my mind. We just got plenty of time. So let's multiply or divide as indicated. So I'm going to do the radical negative 7 times radical negative 7. The first thing I want to do is take out the i's in each one. Then I'm going to multiply like I normally do. I times I. Anything times itself is that number squared. 7 times 7 inside the radical is 49. I squared is negative 1. The square root of 49 is 7. So negative 1 times 7 is negative 7. Easy enough. So same thing here. I'm going to do I radical 6 times I radical 10. I like to put the I in front so I know it's on the outside. And that's going to give me I squared times radical 60. I'm going to break down the 60 to see if it has to simplify the square root. So 60 divided by 2 is 30. 30 divided by 2 is 15. 15 divided by 3 is 5. And I divided by those numbers because they were all primes. Some people like factor trees. You could have done 6 times 10, and then you could have said 2 times 3, and then 2 times 5. They're the same thing, because in both cases, we're taking the square root of 2 times 2 times 3 times 5, because 2 times 2 times 3 times 5 is 60. Right here, I've got a group. These numbers are the same. I squared is negative 1, so that comes outside of the radical. And the 3 times 5, neither of those has a partner, so they stay inside. And my final answer is negative 2 radical 15. Boom. That's been simplified. Same rule with division. Let's take radical negative 20 and divide that by radical negative 2. Well, the first thing we're going to do is deal with the i's. Take the i's out first. Now we can deal with the i's just like we like to. Radical 20 divided by radical 2. That's going to be I over I radical 10 over I. 20 divided by 2 is 10 on top. What I've got, I notice right here, my i's cancel out. Anything over itself cancels out. And that leaves me with the square root of 10. Boom. All right, so when you are hitting this up tomorrow, let's do this in class when we see each other. Give it a shot. See what you can do on your own, and I'll be sure to answer those questions for you when we get to class. If you have any questions, make sure you ask them when I see you, and I will see you when I see you.